Yeah, hello everyone, myself Maruthi, welcome you all to this math video session. In this video, I have taken a topic from trigonometry. In that one, I'm going to explain you how secant theta can be written in all other trig ratios. I repeat, how secant theta can be written in terms of all other trig ratios. That is the concept what we are going to discuss now. Right. So while dealing with this one, let me come back to the main formulas, what we generally deal with the trigonometry in this basic situation. Right. So we'll be having two types of formulas, square identities and reciprocal identities. Square identities, we are having three, as you all know. Sin square theta plus cos square theta is equal to 1. Secant square theta minus tan square theta is equal to 1, which is nothing but second square identity. Cosecant square theta minus cot square theta is equal to 1, which is nothing but the third square identity. Of course, we all know square identities are also called as Pythagorean identities. Now, one more set of identities are nothing but reciprocal identities. We can call them as multiplicative identities also. Sin theta into cosecant theta is equal to 1, cos theta into secant theta is equal to 1, and tan theta into cot theta is equal to 1. These are the square identities, these are the multiplicative identities. Now my concept is how secant can be written in terms of all other, or secant in terms of all other trig ratios. Means how sin, cos, tan, cot and the cosecant can be written in terms of secant, So let me come back. So here, so what we are having here, so it's nothing but secant we are talking about. Alright, secant, how can we write it out? So when we are dealing like this, first remember only these two formulas, right? Square identities and multiplicative identities. Now let's think on here. Right, where is secant here? We can find secant here. Right, so secant is related to tan in terms of square identities. That's what. Secant, I like to deal with the square identities. So secant is related to tan. That is the first point what we are supposed to remember. That is the first relation. Now, let's get back to this one. How secant is related? Secant is related to cos according to reciprocal identities. That's what our topic is. Secant is related to cos in terms of reciprocal identities. This is what we are supposed to remember. So, how secant is related to square identities and multiplicative identities. First, let us think about this one. So, my plan is, first let's go to tan and cos. Let's write in terms of secant by using these identities. So, just now what I said, right, cos and secant are related in terms of reciprocal identities. Now, I am going to the cos here. First, let me write it down. What is cos? So, according to right, reciprocal identities, just now we have discussed there. What is that one? So reciprocal identity 2, just now I have shown you there. So what is that? Secant theta into cos theta is equal to 1. This is the relation what we have. Now, I am writing cos theta is equal to 1 by secant theta. So, this is our ultimate goal. The first one is completed. What he is asking? He is asking us to write all of the trig ratios in terms of secant. Okay, so the first one what I have written. So according to the reciprocal identity 2, just now I have shown you here, reciprocal identity 2, cos theta or secant theta into cos theta is equal to 1. Now cos theta I have written as 1 by secant theta. We are done with the first one. Yes, we are done with this. Now let's get back to how secant is related to one more. Secant is related to tan. Let's write that one. So what it is saying? According to the square identity 2. What is the square identity 2? Just now I have said to you, that is nothing but secant square theta minus tan square theta is equal to 1. This is the second square identity. We want to tan in terms of secant. So what I am writing? So I am writing, we know that one, right? Tan square theta is equal to under root secant square, or just let's remove this one. So tan theta is equal to secant square theta minus 1. You might have got an idea how did I have written. So we can write it down, secant square. What I have done here, I have shifted 1 to this side. So if the 1 comes here, it becomes minus 1. The square here, right, the tan square, if it goes to other side, it's nothing but under root. Therefore, tan theta is equal to under root to secant square theta minus 1. So we are done with the two things, right? We are done with the cos and we are done with the tan. So these are the three relations what we got. Right, with the help of reciprocal relation, I have written cos in terms of secant, and the tan in terms of secant also I have written by using the square identity, right? Square identity 2. We are done with this. We are very simple from here. Now let's get back. We need more. How many are there? 1, 2, and 3. We are having 3 more. Right. Now what is the logic what we have to think of? Let's come back to the figure what we have learned here. So what we have written, secant is related to tan in terms of square identity, right? How many types of identities we are discussing here? We are discussing secant square identities and also reciprocal identities. Now, just now from secant to reach tan, what is the identity I have used? Square identity. I repeat, from secant, what is the identity I have used? Square identity. Now, in a planned way, I am using again reciprocal identity. How tan is related to whom tan is related? I can say, if you check it out, tan and cot are is equal to 1. Tan to cot is equal to 1. Means tan is related to cot. Okay, tan is related to cot. Means to reach secant or from secant I can come to tan. From tan I can come to cot. That's a beautiful thing. So let's listen to me now. So we want to reach to the cot now. So let's go to the cot now. Okay, so what is cot saying? We know what is the identity what we want to use it? Reciprocal identity. How tan and cot are related? See here, tan into cot is equal to 1. That's what from multiplicative identity or reciprocal identity 3, from reciprocal identity 3, what is the relation which we got? So tan theta into cot theta is equal to 1. That's cool. That is the multiplicative identity 3 I have written. Now what I am doing, I am leaving tan, right? Cot here I am writing 1 by, I am sending tan, transposing tan to the other side. What did you get? 1 by tan. It's cool. So what is the meaning of cot here? Cot is nothing but 1 by tan. So what is the meaning of cot? We went to tan. From tan I like to go back to secant. I repeat, where we are here. So we are here at cot. Cot is nothing but from reciprocal identity it is related to tan. Now tan is related to secant with the help of square identity. Now what is tan? Already we have chosen it, right? What is tan according to secant? We are already ready with that. So just you write it down. It's nothing but 1 by, what is this one? Under root secant square theta minus 1. So now what did you get? So cot theta is in nothing but 1 by secant under root secant square theta minus 1. So I repeat. What repeat? First from secant I went to tan. Yes, I am ready with secant to tan. It's straight away square identity. Alright. Now from secant I went to cos. Secant I went to cos, multiplicative identity. I want to take the help of these two and get the other. Right, means indirect relation. Directly secant is related to tan with the help of square identity. Directly secant is related to cos with the help of multiplicative reciprocal identity. Now I am taking the help of the obtained one. I got already tan, but clearly one more logic is there. As we have used square identity here. Here I am using reciprocal identity. So tan is reciprocally related to cot. That's what tan is reciprocally related with cot. So from cot I went to tan. From cot I went to tan, but already tan is there. From tan I went to secant. That's a beautiful thing. Okay, now let's get back to one more. So here from secant we came to tan, we already done. From tan I came to cot, we are done. Now let's choose the other track. Right, from secant, where did I go? Cos, by using what identity? Reciprocal identity. What is the other relation left over? Again, we will go for square identity. From cos, I like to go to sine. You know square identity 1? Square identity 1. What is square identity? Sine square theta plus cos square theta is equal to 1. Means, now indirectly, from sine I like to go to cos. From cos I like to go to secant. Let's go. What's the square identity 1? So square identity 1, what is that one? Sine square theta plus cos square theta is equal to 1. Let's go from there. According to square identity 1. What is the square identity? We know that one. So sine square theta plus cos square theta is equal to 1. So what's the track what we have chosen? We are choosing from sine first to reach cos. From cos go to secant. Why? Because cos is already prepared for you. Right. Now let us go for that one. Now can I write it as sine square theta is equal to, can I write it as 1 minus cos square theta? Yes. How did you get it? From square. What did I send? I sent cos square to the other side. Now moreover. So sine theta, now can I send square to the other side? It's nothing but under root 1 minus cos square theta. I'm pure. I'm done here. So from sine I went to cos. But from cos I like to go to secant. But are you ready with cos? Yes, I am ready with cos. Cos in terms of secant is already ready. So what is there? Cos is nothing but 1 by secant. Means in the place of this cos, I like to keep 1 by secant there. So which is nothing but under root 1 minus bracket square. In the place of cos, I like to keep 1 by secant. That's the logic for us. Right? Means from sine I went to cos, from cos I am going to secant now. So what I am doing, just let me open that for you. So it's nothing but 1 minus 1 square 1 by secant square theta. So what did I do? I took the square inside. Now let me go back here. So which is nothing but under root, let me take LCM there. It's nothing but secant square theta. Okay, if there is nothing, it's nothing but 1. 1 goes in secant square, secant square into 1. It's nothing but secant square theta. Minus is there means minus. Now secant square theta goes in secant square theta 1 time. 1 into 1, it's nothing but 1. Okay, I took LCM, I took LCM. Now again, I want to split that square root. So square root means it's coming to only the numerator, secant square theta minus 1 by secant theta. What happened? Why? Because, of course, I like to write it down like this. Otherwise, if you want, I have splitted the square root. Now it is becoming under root secant square theta minus 1 by secant theta, means the square and the square root has cancelled. So what did I get now? So I got sine theta is equal to under root secant square theta minus 1 by secant theta. Yeah, I am ready with the sine. So if you check it out, from secant I went to tan by using the square identity 2. Okay, from secant I went to write square identity 2, you got it. Now from secant I went to cos with the help of square reciprocal identity 2. Yes, done. From tan I went to cot by using reciprocal identity 3. See here, after square I am using reciprocal. Here after reciprocal I am using square. Always opposite matching up. Okay, so how many are done? 1, 2, 3, 4. 1, 2, 3 and 4 is ready. Now what is left over? What is left over is nothing but we are left over with the cosecant, right? Straight matching. See here, after square identity I went to reciprocal, right? After reciprocal I can go back to again square, but if I go to again back to square means it may go back to tan. Okay, by using the square hundred. But logically what I am doing, right? Sine is related to cosecant in terms of reciprocal identity 1. We know that one. See here, sine into cosecant is equal to 1. From cosecant I want to go to sine. See here, cosecant. So according to reciprocal identity 1, what is the reciprocal identity 1? We are having sine theta into cosecant theta is equal to 1. So what we need? We want cosecant. Let me leave that cosecant there. So cosecant theta is equal to 1 by sine. So where did I go? From cosecant I reached sine. But sine is already waiting for us there. What is sine? Under root secant square theta minus 1 by secant. Why can't I plug in sine there? So which is nothing but under root secant square theta minus 1 by secant theta. What's there? So what will we get? 1 by, oh, I think I messed up here. Now let me write it down clearly here. It's nothing but 1 by sine. Right? Here what we are getting? It's nothing but 1 by so and so is there. So now what I am supposed to do? So 1 by so and so means let us flip it up, right? If you flip it up, what we are getting? Cosecant theta is equal to, if you flip this one, we'll be getting secant theta by under root secant square theta minus 1. Okay, so let me repeat the concept for you right clearly. What is supposed to? Secant should be written in terms of all of the trig ratios. So secant in terms of sine, secant in terms of cos, secant in terms of tan, all he is asking. So what are the trig ratios or identities we know? We know square identity set of 3, we know multiplicative identity set of 3. By using this, I like to write everything. So what I have chosen? I have chosen the track. Secant is connected to tan with the help of square identity 2. Tan. So I have written square identity 2 and I have obtained tan. Again, secant is connected to cos in terms of reciprocal identity 2. So reciprocal identity 2 I have converted. Now I took these two as base. From there onwards I am building. Right. So now tan is connected to cot in a reciprocal identity 3. Tan is connected to cot. So I went to cot here. Tan into cot is equal to 1. So cot is equal to 1 by tan. But tan is already there. I had been there. Okay, now again, cos is connected to sine with the help of reciprocal identity 1. Reciprocal identity I have written, I want in terms of sine, so I have sent to cos to the other side, but cos already I know it is nothing but 1 by secant. I plugged in there and I have simplified. So I am ready with 1, 2, 3, 4. What is the only one missing? Cosecant. So what I have chosen, the easiest one of the square and the multiplicative or reciprocal identity is reciprocal identity. Therefore, how is cosecant related to sine? That's the reciprocal identity 1. I have written a cosecant is equal to 1 by sine. So 1 by sine is already ready because that is 1 by, so 1 by under root secant square theta minus 1 by secant. I have flipped it. I got cosecant here. So what did I do? I have written secant in terms of all trigs. In this channel, I have been placing both math and science videos.